A very good morning to everybody. Today we are presenting ArcGIS for creating a digital mesh for digital twins. All of us knows that in the recent geospatial policies, this has been a focus area for creating the digital twins. In that respect, we have keep this session. I and my colleague Krishnendu will take you through the digital meshes, how it can help in creating digital twin and what are its importance. So welcome again to everybody. If we try to define a digital twin is basically a virtual representation of a city system that spans its life cycle and is updated from real-time data. It uses simulation, machine learning, and reasoning to help in decision making. Going in depth of it, so currently in 2D domains, we cut our physical entity or geographical entity into different layers. In 3D also, similar type of entities will be created, like buildings, infrastructure, mobility, digital layers of smart city, which is also a part of current smart cities, but it will be in 3D layers. And finally, the virtual layers of digital twin, whereby you can see that new stuff has come up, new features has come up on the geographical space, and we are experimenting with that. So we have tried to create similar type of digital twin for Varanasi city. So these are a demonstrable area in Varanasi city, whereby we have created the 3D type of land use. It depends upon the land use. We have classified the buildings, and you can see the color coding as the land use goes. So residential for yellow for residential color, blue for utility buildings, red for commercial buildings, orange for mixed land use. So that sort goes on. Then a 3D utility levels has been created, whereby all the manholes and the utility networks has been created in 3D, and it is as per the actual depth. This is for only the sewer infrastructure was created for Varanasi city. This is again some type of analysis on the top of that. You can see that there are yellow lines, orange lines, blue lines. These are real-time traffic data. So it is covering the mobility aspect, that is what is the real-time traffic data, how it is looking, and where the traffic congestions are in real time. Then we have on the top of that different data from different sensors. And this is for traffic light. So two type of analysis from planning aspect. We have created the buffers of 1.39 meters along each of the street lights and tried to see which areas, how the distribution of traffic lights are in the roads. And then we also can generate that which traffic lights are working or not working. So that type of analysis has been undertaken. And finally, we can also see the impact of different type of projects. So this is area development projects, creating the pedestrian ways along the buildings of different type. So that type of aspect can be put over to see the impact of that in 3D arena. Now, why we need this digital twin? So you might be thinking that, okay, that we can do in 2D also. So 3D provides you a simulation, a similar way. Human beings are more accustomed to see the virtual world. They can undertake the planning in a better way if it is the virtual world. So real-time data, as I have told you, different layers will be used. And then this 3D platform will be used for testing and analysis of different parameters. Parameters like city design, if we increase the size of buildings, if we increase the green space, we can play and plug with this aspects in real time, and the final implementation will be done in the real world. So that is the basic objective of digital twin, to provide you a 3D platform to understand the complete impact of whatever aspects of development we are doing on it. And the most important aspect is the data need to be continuously updated on it. So for creating the 3D scape, the drone and LIDAR data will be used for actual land uses that are happening. Then all the sensors which are currently used in smart city, with the sensor revolution, this will go on increasing. And then there will be also AR/VR technology, which is coming up with for analyzing the things in a real world situations like that. So the digital mesh in GIS will be created for the complete city, for the features and buildings in the city, for outdoor atmosphere of the cities, for indoor aspects of the cities, and for facilities, buildings, rooms, and structure. So it will be like a real world that this type of digital mesh will be created. It depends upon what is our objectives. So someone's objectives can be only for infrastructure. That time we will create the infrastructure details only. But if it is about the complete city, then all this need to be, the levels of details goes on increasing till the single unit in which we can do the planning of spaces also inside any particular type of building. And for this, a huge storage will be required. This data will be heavy, and so we prefer that type of model to be built on cloud technology. Now, the inputs of this city. So it will come from LIDAR or drone. As of the current technology trends are, it will be coming from LIDAR is a light detection and ranging technology. The lights thrown from a sensor are reflected back and depending upon the reflection amount, the different materials or the different objects are identified. It looks like this. From the LIDAR, we can identify different sorts of buildings and then we can create the features. So building, plants, roads, bridges, all can be identified or created through the accumulation of those points. From this point data, the LIDAR data will come in the point LAS format and it will be converted into different type of structures. Similarly, drone survey. Now you can see that for drone survey, we can divide that. Okay, for we need to plan out where we are carrying forward this drone survey. So accordingly, the sensors will be used in it. Suppose we need a complete 360-degree view of a building, of an important building, then we create this type of cylindrical option so that the cameras can collect the information in a 360-degree mode of a particular type of buildings. And we need to see the areas which need to be covered for other general things. And through that, we can create different type of models. We can create digital terrain model. We can create digital surface models. We can create contours, we can create orthomosaic, we can create point data, we can create meshed data, orthomesh data. And this data will serve as the base for your digital twin. Over the top of that, you can use AI tools to extract different type of features which is required by for your analysis and for your deep development. So this is like identification of all the buildings. For that, we train the signatures of the particular buildings and it automatically find out all the buildings and create the data. So as this procedure has reduced the time span of data creation for us. And more we train the features, like buildings in India are of different types. It is made up of different materials. So all this need to be put up. So the training need to be for different sets. more you select the type, more accurate the data will be. Similarly, you can identify the infrastructure detail also. So 50,000 man hours per year can be saved by using the drone data for creating and moreover, the complete infrastructure is in 3D format. So this is for identification of power infrastructure. This is another model of it. So you can even find out the linkages to the individual houses also through this. You can see that this point data can help you to identify where the poles are, where the transmission line goes. Similarly, we can also identify all the trees inside the urban areas. So this type of feature extraction helps in improvising the data set for your deep analysis. Now coming to the utility features, because utility will be a very important component in our digital twins, and we promote to use utility network models. Let me briefly tell you what is utility network model. Up till now, we have been habituated of seeing the geometric networks. These geometric networks are lines where we identify it as a topology and add the data to it, and we do the query and analysis. But utility network models are connected networks. Connected network means it is based on a complete rule and analogy, that which type of pipelines are there, what types of valves are associated with it. Suppose a household, individual person is asking for a network connection from his house to the main distribution line. So the complete set will come with a gate valve, with a scour valve inside it, the complete connected network will come. Inside the pumping station, it will come with all the different sorts of valves, all the equipment that is required for a pumping station, for a WTP, for a STP. So that type of complete connected network concept is known as utility network model. And why this is promoted for a digital twin? Because we need to see the complete inflow, the directions of flows, the direct pressures need to be maintained through a complete modeling environment, so that when the field guys will go, they know that it should actually simulate the real world in terms of all the components inside the pipeline, the real flow of water. So that can happen only when you have transferred that to utility network model. Now these models with their specific components are there for water, fiber, telecom, electricity, and sewer lines, drainages also with the domain-based contents. So the domain-based contents means which are the fittings which are used in gas pipeline, which are the fittings which are used in water pipelines. So those differential things are also there in utility network model. And it also captures, it is capable of capturing all the different type of maintenance activities that are being taken. Maintenance or regular construction activities also, whatever are done in those networks are getting captured in the data models. So we have space for that. And it helps in creating the DMAs. It helps in analyzing the input and output of waters. It helps in looking into the electricity load distribution. It helps in the telecom network. How is the what is the tower strengths of real in a real time? That type of analysis can be undertaken. So this utility network models are industry focus, which is configurable for particular types of utilities. These are scalable to operate at all scales. This can be from a city level to, suppose it's an airport building, so you can go into individual network details inside the airports also. It can be for buildings also, that this is the scalability aspect in that. It is future proof. This type of service-based architecture are important for next generation network management, because it needs to be a complete secure data access system. So digital twin will operate providing the entire data access security is maintained. Then, as we are talking about, it is an integrated network. It captures the operational requirements of the utility assets. So if any type of anodization is created, cathodic activities are put up, pipeline security is maintained, injections are put up, all these activities are also getting captured in utility network data models. And finally, it provides a data quality. Network and attribute rules are provided. So when you are in geometric model, you have to put up the valve size according to your own thing. But in network data model, that will be according to the distribution pipelines actual width or diameter. So that is how the complete quality control in attribute rules will be followed in the complete system. And then you can do different levels of analysis on the top of that. You can integrate it with the SCADA system for real-time operations, for pressure flows, for the flow directions, for pumping stations, for energy that is used in the pumping stations. So that type of real-time feedback will come to help you in managing the system in a digital twin. And it will also provide you the benefit of understanding that what is the depth of each of these layers. So that when you dig or when the maintenance activities are taken place, it is easier and it is cost effective. Now, the next part, the traffic services, as I have shown you in case of Varanasi city. So you can, in ArcGIS Living Atlas, you have a component of World Traffic Services. It works similar to like in Google, Google's day-to-day, whatever we can see that how traffic is happening. Here you can keep a tracking also from this time to this time, how the traffic has changed. From this date to this date, how the traffic has changed. And you can find out that which are the bottlenecks areas in a particular city, and then you can overlay that over the digital twin model, and you can do different levels of analysis. So traffic analysis, accident analysis, because it will be based on the cameras also. So cameras will be installed at different places to understand that where the collisions are there, where the pedestrian movements are there, where the cyclists are moving, where the motorists are moving, and also the air quality predictions, because we are keeping that sensors also in our smart cities. So in digital twin, that can serve in a better way, because we would understand the sink area and the dispersion areas of air pollutions. This is again another view of it. So we have created this geofencing area, so that whenever any motor is coming out, so we can the camera can detect that. So camera can detect the pedestrian, camera can detect the cyclist. So we can put it to different type of users, like which are the areas where cycle movement is more, which are the areas where pedestrian movement is more, so that we can plan accordingly the non-motorized areas in the cities. We can also see the traffic analysis through that which areas are facing the more traffic and the bottlenecks of traffic. Another example, so if we can simulate that all the buses moving, so we can have the different type of GPS based system whereby we can track the movement of all different type of vehicles. So there are buses, there are motorists, there are pedestrians, there are bicycles. So you can put up some chips on the bicycles also, and then you can analyze the complete mode over a 3D environment. That's how it looks. You can analyze because it's a 3D. So you may say that what's the fun in that? It can be in the 2D environment also. Yes, that can be obviously, but in 3D, you can analyze that whether the traffic congestions are because of the high density of the area. Then you can plan out. Suppose you have decided to plan about the road expansion, or you need to plan for any flyovers or underpasses. You can see in 3D scape that how I can plan for. Now the live feeds. Now coming to the, so we have created the complete cityscape, the road and infrastructure and the buildings. And now we have to get the regular feed from different type of sensors. So in 2D atmosphere, different type of sensors will look like that. Suppose there is any fire in the building or some evacuations need to be taken up. We can see in real time that how a evacuation plan can happen, where the people are moving, where the vehicles are moving, how to evacuate the people to safer areas during any type of incidents. You can track thousands of moving objects through these sensors. So vehicles, the metros, as well as the cars on real time that I have mentioned you, that all the types of modes of transportation can be tracked in one singular way, and you can plan for different TOD based planning based on this actual movement of vehicles. Similarly, for unlimited stationary sensors, so these stationary sensors can be from building sensors. This can be the SCADA instruments. This can be the SCADA on electricity. So all the type of stationary movement, and we can then segregate them as per water telemetry, as per electricity telemetry, as per buildings, different IoT instruments, and then we can decide upon that which are the areas of which are the problematic area, or which are the how the load is distributed for the things, or where from the pressure details are coming up, where the pressure locks can be created, and also the social media. So this is the socially how people are discussing on whatever aspects in the city development are there. So we can track that also. And finally, all the rest of the IoT things. So that is for camera, that is for environmental sensors, that is for traffic light sensors. So you can find out that where they are working, where they are not working. From the data, you can gather that how much traffic has gathered at a particular location, where the crimes are happening. So security, surveillance, daily operations and maintenance can be undertaken, and all that can be put over the real-time 3D substance. So first I have generated that in 2D, and then I'm showing that if we are putting it on digital terrain, what will be the impact. So this is one example of illegal parking when people are reporting this illegal parking area. So how many requests are coming up from a particular location, or a camera is detecting over a particular part of day that how many illegal parkings are happening and in which part of city it is happening. Similarly, for sanitary conditions, so where the dumps are deposited in an illegal way. So this type of 3D modeling can be created. You can locate that where from the complaints are coming up and which part of city, how the things are changing up. Then blocked driveway, it is again coming from the cameras that where the driveways are blocking and people are complaining about it. So this is how it is changing. And then water systems. So water system complaints, where from it is coming during which part of the day. And you can see that this changes, and you can also have them in different types of chart visualization, how many number of requests are coming, and you can analyze it based on from which part it is coming, how many requests are coming from which part of the city, at which part of the day it is coming up. So that type of analysis we can create by hourly measures, by locational measures, and then we can provide better solutions. Next, we can come to the GeoBIMs. Now this GeoBIMs, as I mentioned, that from the cityscapes to the building level, we can have different scales of digital twin. So GeoBIMs are already an existing reality. So we are analyzing the details of development of the building over a geospatial environment. So this is for another view of it, whereby the airport buildings have been looked after there, what type of infrastructure are there. So you can see that if there are any problems in any part of network, it can get detected. And when it is in 3D environment, when it is on BIM model, then it is easier to address all those issues. This is how we develop that. So duct fitting, you can see that with the complete details, building at which level it is, so which floor it is, what is the elevation, what is the building, which story it is located, what is the room offset of it. Every details can be modeled inside the GeoBIM models. You can also fix up the interior space, that how we are managing the space, how we are managing the gates inside the airport building, and you can check with the different service layer for different parts. How is the ramps, the plumbings, the floors, the furniture, the staircases. So all that can be managed using the BIM models. Similarly, we can put up the infrastructure in these details. So for any building, so if CAD drawings are there and we know what is the depth of each of this network lines, we can even start with the as-built drawings. If it is not available, then we can go with the GPRs. Okay, but currently GPR technology is costly, but we can also use the CAD drawings for the particular things. And when we put that in a GeoBIM model, then we know in real times how these fittings look like. So it looks like this, that where the infrastructure are, and it will help your digital twin in fixing up any real-time problems. You can also see the hydrant over the top. So the top, and when you cut across the bottom, you can see all the infrastructure in their defined form in the real world format. So this is the simulation. So BIM plus location data provides you better design and long-term savings. Now it is coming up. ArcGIS has already developed augmented reality model. So there are mobile applications which are being created using XR data formats for the BIM modeling, through which you can see a field operator can see where the pipelines are lying when he is moving over the surface of the road. So this is going to be not very matured yet, but this is also going to be a part of your digital twins, because that will help in operation maintenance of the complete infrastructure. China has, ESRI China has used this AR for field operation. On the surface, you can see that it is like PUBG game, that you can see where my manholes are and where the pipes are linked in what format. And you can see on the top that how this is linked. So there will be the mobile apps which will help this field staff to identify where the actual networks are lying, so that any problem can be detected fast and managed in a faster way, which will be cost saving to the city administration as well as the citizen services will be augmented. And finally, why we use this? We are using this 3D digital twin models as a platform to plan out different substances. So suppose you are planning out the pedestrian paths along the road. So you can see that if I plan out the pedestrian path, or I can do the model splits in 3D environment, it is very easy because you know where I will put up my lamp post, where I will put my traffic signal lights. So this is a junction plan can be undertaken in 3D environment in a very easy manner. So this digital twin model will provide you a platform whereby you can see the impact of your different development in a very easy fashion. So where my best stops I can plan, where the waste bins I can plan, how the city beautifications can take place. And lastly, I would discuss about how this digital twin can be put up for different use cases. So for disaster, you can look for the fires are regular incidents in very congested parts of cities also. You can also plan for that fire ladders have a particular height. So how far the fire ladders can go. Above the fire ladder's height, the buildings need to take take the fire NOCs compulsorily, and they need to plan for the fire meeting of the fire event. In disaster can be used for flood modeling. We can see if for 1 meter of rainfall, which are the areas which are going to get inundated, and which are the buildings and which is the infrastructure which is under vulnerable conditions from that flood. You can also see from the 3D models that which are the areas where the landslide can happen. Yesterday only, you might have seen in the television that in Raigad the landslide had happened and 9 people have died. So this happens when you are working in a 3D model. That time you have a digital surface model as well as a digital terrain model, and you can identify those areas which are susceptible to landslide during the rainfall areas, and you can take the preventive actions. And actually the people who are less privileged generally stay in these areas. They are already underprivileged, and then also they are also having these problems of landslide. So the building construction, so zonations of the city can be more accurate when we plan it in 3D environment for the resiliency of city aspect. Next aspect is land use. So a 3D land use helps. How it helps is that because we are trying to promote more of mixed land use. So how this 3D land use can be planned, which parts of buildings are for commercial users, which are for residential users, which among it are utility. We can create that type of environment. We can also analyze the building density. Building density is because we are talking about compact city development. So building density is one of the inference that will provide you an idea that, okay, this area and how I need to plan for the increasing the density of that area, increasing the FAR of. Now we are also having this TDR based plan. So we can also see that how the building density is going to impact that type of development. Green buildings. So green buildings is futuristic norms looking into all the type of climate oriented hazards. So we can plan for, based on the roof area, we can plan where how much is the solar power generation potential and what is the water harvesting potential of those particular buildings. Because this will be the tomorrow's norm for the green buildings. Transport, we can see, as I have shown you, we can see the different vehicles, different modes of transportation inside the city using the cameras in a 3D environment, and we can analyze that how to manage the traffic in a better way. The BIM models will help in project planning in a smoother way, in a faster way. GeoBIM specially will help to analyze that at which phase the constructions are and how efficiently. See, one of the problems why our infrastructure projects are delayed because we don't yet adopt the GeoBIM models. So suppose we have analyzed the GeoBIM model in a 3D twin surface, then we can see that how efficiently we can construct, and then construction can be planned and the projects can be completed in time. Tourism aspects. So we can plan for different levels of LODs, level of details for heritage spots, and we can help people to appreciate those heritage buildings in 3D environment, and accordingly the tourism can get a boost inside the city. We can also plan out the buffer areas, the beautification of those tourist places, and how the infrastructure planning, we can also do the local area plans for those tourism things, that how they can be conserved in a better environment, in a 3D environment, so that the others buildings shadows does not impact them, or the building height of other places are not impacting those heritage buildings. Green space access. So green space, we can divide the green spaces in the city in different categories, like neighborhood park, community park, city park, and then we can see that how many people, what building heights can get access to this parks easily based on our town planning norms. And we can also in 3D scapes then see that to beautify our city or to increase the green space, which are the areas available. So in 3D, that as it is the simulation of the real world, this becomes easier, and in a better way we can plan for the green spaces and for the parks. We can plan for the infrastructure. We can put up different types of projects and we can see the impacts. It can be from simple pedestrian footpaths. It can be for different types of buildings, which when comes up, how it is going to change the cityscapes, how much traffic it is going to increase. Suppose a new township is coming, what will be its pressure on the existing transport network? All those things can be, and we can plan in a better way. So how to access the schools, the hospitals, the police stations, or any other facilities, or how the fire stations, fire vehicles will move. So this type of project impact analysis can be better undertaken in the 3D environment. Citizens' grievances. So citizens' grievances in a 3D environment will tell us that how tall the building is where from the citizen is raising the particular type of complaint. So how I can manage the infrastructure in a, suppose there is a complaint for water supply, suppose there is a complaint for electricity, how that can be managed. When you know the heights of the building, it makes the address to those grievances easy. City design aspect, where the new buildings are coming out, how it is going to change the city design, the infrastructure wise, or you want to do the city beautification. So cities like Ayodhya, where they are planning for a complete facade change. So how this facade change is going to create the impact on the overall beauty of the city, that can be looked out in a twin cities in a better way, and data updates. So from sensors will go on increasing the miniaturization, or sensors is revolutionizing this aspect. So the data will be updated from these sensors and we can take the analysis in the real world. Those are the use cases. Now I would hand over to my colleague Krishnendu, who will show you how this digital twin aspect is possible using the ArcGIS technology. Over to Krishnendu.
Thanks, Roma. So I will be taking you through how you can create a digital twin with ArcGIS, basically ArcGIS Pro and ArcGIS City Engine. So let me take you through my ArcGIS Pro demo first. So in a digital twin, we will be creating multiple level of details. So let's see how we can create a level of detail one within ArcGIS Pro with a digital elevation model, DSM. I'm having a digital surface model here from which I am taking the elevations to my building footprints. So these building footprints are generated using AI, but currently it is not having a building height. So using a model created in ArcGIS model builder, I can extract this building height this can be a repeated process when you have multiple cities, multiple building footprints and different DSM. So you can create this kind of a model and extract this. And once you did this, you can simply go for the extrusion based on the base height and you can select your building height fit. So this will help you to generate a level 1 of visualization. And for a context, you can always have the 3 points if you have that with you. And here, if it is a point, you have the options of giving the symbology like 3D animated symbologies are already available within Pro. Or you can go for the 3D realistic symbologies, which is also available with inbuilt. Now let us see how we can create a level LOD2. So for that, we have inbuilt solutions available with ArcGIS. So I have downloaded the 3D building solution and I have taken the toolbox from that. So here also we have the footprints from AI model and I have run these tools from the toolbox and it is giving me an output of footprint multipatch. So if you just take a look, it is already detecting the roof types and roof forms. So for that, what we are using is the DSM and DTM and normalized DSM using the raster calculator. So once we got this, we can say like always the AI models will not give you the 100% accuracy. So we need some manual interventions here. So I'm going to do some editings here. So within our ArcGIS Pro, we have multi-patch editing capabilities like this. We can edit the vertices and all. So suppose you see this building is not going to be like this. I can use the edit vertices option and edit this building always. So I can build this. And if I feel like, okay, this is the roof type, I can directly apply that roof type from here. And you can see the building texture is different now. So that's where we can use the multi-patch texture tool. And you can select the color or you can always load a texture from here. So using the load texture option, you will be able to load any texture or facades which you have already and apply that to the building. So like this, you can quickly create a LOD2. Now, let me showcase you how you can quickly create a LOD3 within ArcGIS Pro. So here I have the building footprints here. So to this building footprints, I can quickly apply a rule package file. So rule package files we can create with the help of ArcGIS City Engine. So I can just select the rule package file from the properties of the symbology. And once that is applied, you can select your building heights and all those things from here. So you will be able to connect this from your attributes. So likewise, you can play with multiple rule packages. So I have some other things also, which is similar for Indian scenario. So here I can select my building height, which I am connecting from my base shape file. And also the roof type information I am having with this. So I'm connecting this. So once I apply this, you can see how quickly I am able to create a LOD3. So this will take some time to load. So similarly, I have created the trees also. This is also created using the RPK files. Now the question is how we can create a RPK file. So that's where City Engine is coming into the picture. So City Engine, ArcGIS City Engine is a different desktop software which enables you to do procedural modeling. So for the procedural modeling, you have the City Engine where you can start from a blank canvas where you can have your building footprints and everything. And also you can start using get map data option where you can import your set by extent, import your SD world elevation base map and also networks and footprints from OSM. So I have already taken these things. So you can see here. So I have clipped the network for my area of interest. So sometimes what happens, OSM layers will not have all the street networks and all. So you can just use the street creation tool within City Engine to connect the missing networks, and you can create your network like that. So once this is done, you can clean up it. So that's it, your road network is done. Now let's see how we can apply the CGA rules. So CGA rules, that's the basic of the City Engine where you apply the procedural modeling. So these are the CGA rules which I have with me. So this is a simple extrusion rule. So you can select your buildings from here and assign the rules. So once this is done, you generate, you have the LOD1 kind of building. Likewise, I have multiple CGA rule files available here. This one is having some more details like building footprints to roof type. So let's try that one. So now we can see we have some more information of the roof and everything. And likewise, we can add facades and objects and make more detailing to your buildings. So this one is having some more information like facades and all. And similarly, what we did in the Pro, we can connect your attributes from here. So once you select, you have these many attributes which you can connect. So I'm currently connecting our height information from our building footprints. So you can just connect the attribute, select your shapefile, and select the attribute. And similarly, you can connect your roof types and all. So let me showcase you how this is actually making a difference. So if you see from this side, you can see there is a window and all these features are coming. So these are connected with objects and facades. So this kind of detailed modeling you can do with City Engine. So similarly, you can do for your tree polygons also. So you can just assign the role file. And you can connect the attributes from the attribute area. You can go for any trees you want. So we have these many inbuilt or realistic tree options. So you can select whichever is matching your area of interest and you can generate this. So likewise, you can create a many level of detailing. And we also have an option to connect your ArcGIS Urban models here and develop it. So now I have a model which I developed for a bridge. So this is a sample model where we can understand how actually digital twins are working. Digital twins are not only about the 3D building models and all. As you know, digital twin are the collaboration of all other details and data. So I have published this. And you can see I have integrated a simulated sensor data here. So this sensor is showing the structural monitoring. So you can see the received time, last received time, and the temperature. So likewise, you can integrate all your city sensor data into a digital twin and have that actual experience. Okay, this is what's happening in my city. So I have another use case also. This is for flood inundation, how a flood levels are interacting with your city. So we have a 3D model here. Now let's see in a 1 meter flood, which all areas are interacting with this. So these many areas are having the impact. And likewise, if you increase the levels, you can understand, okay, these many areas will be underwater. So this will help you to, if this kind of models will help you to plan your city accordingly. And also you can use this for disaster preparedness. So that's all about the digital twin creation, and these were some of use cases. Now we are open for questions and answers. So you can ask the questions in your chat option.